Kayla and Paula are to be assigned seats from the arrangement of chairs shown above. If Kayla cannot sit in the same row, either vertically or horizontally as Paula, how many different seating assignments are possible for Kayla and Paula? So let's just think about Kayla first. So let's just think about her possible seats. Let's just think about them in terms of rows and columns, because we don't want Paul to sit in either the same row or column, essentially, because they're saying a vertical row I guess we can view as a column. So how many rows could Kayla sit in? She could sit in 1, 2, or she could sit in the first, second, or third row. So there are 3 possible rows she could sit in. And how many different columns could she sit in? Columns. Well, there's 1, 2, 3, and 4 columns. So this is the first column right over here. This is the second column. That's what I'm referring to as a column. That is the third column, and that is the fourth column. So there's 4 possible columns. So how many different possible seats could she sit in? So possible seats. Well, 3 rows times 4 columns is going to be 3 times 4, which is equal to 12, which completely makes sense. There's 12 seats here. So if Kayla sits down first, let's just assume she does, then there's 12 different places where she could sit down. Now let's go to the more interesting case. Let's go to the case of Paula. So how many possible rows could she sit in? Let's just assume Paula sits down second. Well, Kayla will have taken up one of the 3 rows. Paula cannot sit in Kayla's row. If Kayla sat in the third row, then Paula only has the first or the second row. If Kayla sat in the second row, then Paula can either sit in the first or the third row. So Paula only has 3 minus 1 options, only has 2 rows that she can sit in. She can sit in any row except for the row that Kayla picked. Now, what about columns? Well, the exact same logic. She could sit in any column except for the column that Kayla picked. So if Kayla picked the third column, then Paula has to sit in either the 1, 2, or 4th column. So there's a total of 4 columns. Kayla's going to take up one of them, so Paula's going to have 3 options. So how many possible places could Paula sit? Well, 2 times 3, there's 6 possible seats for Paula. So if you look at all of the permutations right over here, there's 12 possible seats for Kayla and 6 possible seats for Paula. 12 times 6 is equal to 72 different seating arrangements. And it's good to do a reality check here, because if they didn't put these constraints, how many seating arrangements would there be? Well, Kayla could, once again, she could pick any one of 12 chairs. And if we didn't put these constraints about Paula, and assuming Paula doesn't sit on Kayla's lap, then Paula would have 11 seats to pick from. So then we would have 12 times 11 possibilities. But we're going to have fewer possibilities because any row that Kayla picks, we have to essentially throw the other 3 chairs in that row out of question. And every column that she picks, we have to take the other 2 chairs out of question. And just to kind of imagine this a little bit, imagine Kayla sits here. Then you have to rule out this whole column, this whole row. Paula has 6 chairs to choose from. And you could have done this visually. If Kayla sat here, you throw out that row, that column. Paula has 6 chairs to pick from. So Kayla has 12, Paula has 6. 12 times 6, 72.